Hello, my name is Rich Gvuj, and I'd like to welcome you to my 2021 Esri Developer Summit presentation. We're going to be using Coupe to connect a remote data source to ArcGIS clients. So here's the agenda. Do some quick introductions. I'm going to talk about what Coupe is and why you might want to use it. Some frequently asked questions. We'll talk about something called the Koop CLI and using the CLI to set up a Coupe instance. And then we're going to do a little bit of finding your way around the Coupe code base. And finally, we're going to demo developing a new provider. So as far as introductions, it's just me. As I said, my name is Rich Gvuj. I'm a senior engineer at Esri. I work with the Esri R&D group based out of Washington, D.C., and I'm a senior backend engineer for the Hub product. I'm also the Coupe product owner. So when I'm not working on Hub and I have the opportunity, I'm developing the Coupe packages and platform. So what is Coupe? Coupe is really just a web server written in Node.js, and it's based on the Express.js framework. And what it does is it extracts and transforms geospatial data in response to HTTP requests. The transformations that it does are many, but include a transformation to feature service JSON, which allows ArcGIS clients to connect to Coupe as a data API. Coupe has a plugin architecture, which allows customized Coupe instances to be quickly developed. These instances will just have the code that you need for connecting to your specific remote data source and just the code that you need for transforming that data to whatever output format is of interest. And there are many pre-built plugins already available through the Node Package Manager. Why would you want to use Coupe? Well, most often you want to use it if you are trying to use ArcGIS clients, but the data source isn't compatible. So your data source might not be compatible with ArcGIS clients because that data is tied to business applications and it can't be moved into something like ArcGIS Server. Similarly, the source data might be controlled by a third party and can't be moved into ArcGIS Server. Perhaps you could move it, but it's in a data source that isn't supported by ArcGIS Server. So for instance, Elasticsearch is a common data store now, but it does not work with ArcGIS Server. So you may want to get your Elasticsearch data on an ArcGIS web map and don't have any other way to do so. Finally, you might want your data in output formats that aren't yet supported by ArcGIS Server or other APIs. So perhaps you have some S3 data and you need to serve that out as OGC API format. This is a conceptual diagram of the data flow in Coupe. And I'd like to point out at the beginning here that this isn't a one-time ETL. This data flow happens on every request from a ArcGIS client. So on the left, we have data sources that might be something like an AWS S3 bucket or an Elasticsearch data store. And that data can flow through Coupe and be transformed into a format that ArcGIS clients can consume. It's important to note that this is just a conceptual diagram and it doesn't fully capture the request and response data flow that occurs in Coupe. I would recommend, if you're interested in that level of detail, you can go to my 2020 Dev Summit presentation. I think it's under the same title actually as this one, but it's 2020. And I go into quite a bit of detail about how data flows through plugins internally in Coupe. A couple of Coupe frequently asked questions. Is it free to use? Yes, it is an open source product. And is it maintained? Yes, it is maintained. We actually use it internally for part of our hub infrastructure. So we are there and working on it. Where can you get more information? We have a few different places. There is a Coupe documentation website at koopjs.github.io. You'll find a lot of docs there about usage and about development. You can also go to our GitHub org, which is github.com/koopjs. You can also join the spatial community Slack and find the Coupe channel. We monitor that as well. Let's talk about the Coupe command line interface. So what is this? The Coupe command line interface is a tool for quickly setting up Coupe application instances. And it essentially generates boilerplate code for the application. You can use it to add existing or local plugins to the Coupe instance, and you can now actually use it to add HTTPS. If you're interested in using it to add HTTPS, you should go to our github.io page. There's a recent blog post on adding HTTPS to your Coupe instance. The Koop CLI will also run a dev server for testing, so that can be helpful for some. And just to note, it works on the major operating systems of Windows, Mac OS, and Linux. Okay, for our first demo, I'm going to use the Koop CLI to create a Coupe application instance. I'm going to start by showing how you install the Koop CLI. Very straightforward. Expects that you have Node.js installed on your machine as well as the Node Package Manager or NPM. Given all that, you can just do an npm install at koopjs/CLI at latest. That's going to give you the Koop CLI, the latest version of it, and it's going to install it globally so that you can reach it from your terminal. So we'll just let it install. Great. So it's all installed, and if you do a koop --help, you'll see a list of all the commands that the Koop CLI supports. We can talk about these in a little bit more detail as we go, but you can read a brief description of each of the commands with the console printed help. All right, so if we want to generate a new Coupe application instance, the Koop CLI makes that really easy. That is simply Coupe, and then you're going to add, Coupe new app, and then whatever you want the Coupe instance to be called. This is really just for directory naming purposes, but here I've called it Dev Summit Demo. So Coupe new app Dev Summit Demo. And I'll fire that off, and in the background, Koop CLI is going to create the project. It's going to create a Git repo, add some configuration and boilerplate clip code for us to start working with. And there, it's done. So if I cd into this directory, you can see that it's already a Git repo, and you want to take a quick look at the file structure. We can do it just like that. And that's what we're starting with. That's the Koop CLI has generated all of that code and all those files for you. I've opened up the directory in Visual Studio Code so we can take a look at what's actually been created. You'll notice a config directory along with the default config file, the node modules directory, and then most importantly the source directory. All right, I want to draw your attention to the index file. It is the file that Node is going to be executing when Coupe starts up. You'll notice that a new Coupe app gets instantiated, plugins get registered, any additional routes get registered, and then we start listening on a certain port that is defined in the configuration. If we look at that configuration file, you'll see that the default port is 8080. So if you wanted to change that so that Coupe listened on a different port, this is where you do it. Before moving on, I thought I'd talk about this plugins.js file. This is where all the loaded plugins are going to be listed. You'll notice that we don't have any plugins listed here right now, and that's because we just created a new Coupe app without adding any plugins to it. So right now it's just empty arrays. There's also a routes file, and these are routes that are specific to this particular Coupe application. Providers have their own routes, as do output plugins. But these routes here in this routes.js file are specific to this application. So if you wanted to add additional routes to your application, then you would do that here. And you do that with by adding objects to this exported array. And the objects have to have a path. They have to have a list of supported HTTP methods, and then of course a handler for handling the request and sending back the proper response. Now we're going to add a published data provider to our already created Coupe instance using the Koop CLI. All right, the next thing we're going to do is we're going to add a provider plugin to this Coupe instance. And we can do that with the Koop CLI by doing a simple Coupe add provider and then giving the npm name of the provider we want to add. So in this case, it's Coupe add provider at coop.js/provider Socrata. That's going to add the Socrata provider to this Coupe instance. It's been added, and you'll notice a few different things in your code base. If you go to your plugins page now, instead of an empty plugins array, we've got an array that includes reference to the Socrata provider. And it's not a direct require of the npm. Instead, it's requiring a local file. And that local file is really just it's just a wrapper around the actual npm. So nothing special there. All right, so now that we have our Coupe Socrata provider installed, we can start up the Coupe instance and take a look at the console output and talk about what routes are available right out of the box. So Coupe serve at the root of your directory will start up the Coupe application instance. Now you're going to see this output whenever you start, unless you've disabled the console output. And what you're going to see is the Geoservices output routes for the Coupe provider, Socrata provider. So what this is saying is we've got Coupe provider Socrata installed, and it's been combined up with the Geoservices output plugin to give us this set of routes that we can use. Now the Geoservices output plugin is particularly important for those of you that want to use Coupe to serve data to ArcGIS clients. And that's because the Geoservices output is able to understand requests from ArcGIS clients, and it's able to send back data in a format that ArcGIS clients expect. And it does so with all of these routes that are listed here. Now I want to talk about 4 of these routes in particular, because these are the ones that the ArcGIS clients really use for the most part. And it's these 4. It's the feature server route, the feature server layer route, feature server layers, and the feature server layer method route. As an aside, notice that we've got 4 very similar routes here, the exception being that there's no REST services in the route string. When Coupe first came out, we had just these routes here, but we've noticed for some clients, ArcGIS clients, to work properly, they really need to have REST services in the route string. So we're recommending that you always use these 4 feature server routes that include REST services. In a future version of Coupe, these will be deprecated. In addition, you'll notice a couple other routes on here. These here, the REST info and the tokens routes, really only involved if you've got the authorization plugin installed. And in this example, we don't, so you can ignore those. These wildcarded routes down here are really only there to provide an endpoint to get dummy responses from Coupe to ArcGIS clients that happen to request them, so they can be ignored. Let's take a closer look at one of these provider routes. Take a closer look at one of these feature server routes. There's really 2 sections. There's this first part of the route that comes from the provider, and then the second part of the route that comes from the output plugin. And you'll notice this first part includes the provider name, this REST services string, and then these 2 route parameters. These route parameters here, host and or ID, are defined by each provider. The provider configuration determines whether or not these host and ID parameters are present at all. And the provider documentation should tell you a little bit more about what they represent. Second half of the route is defined by the output plugin. Has added this feature server string as well as 2 additional route parameters, a layer index, and a method parameter. It's useful to add a second provider plugin and look at the console output in order to see the pattern of how these routes are composed. So now I've just added the file GeoJSON provider to our app, and I'm going to start it up again. And I'm going to start it up again. And now you're going to notice something different about the output. We still have these routes that I was talking about earlier, these feature service routes attached to the Socrata provider. So here's the Socrata provider, REST services, host ID, feature server, etc. Down here, now that I've added a second provider, there are very similar routes. The only thing that's different is this set here, instead of saying Coupe provider Socrata, it says file GeoJSON. File GeoJSON is the name of this provider. And you'll also notice that instead of having host and ID, it simply has ID. And that's because this file GeoJSON provider only defines one route parameter, the ID parameter. Okay, let's talk about actually making a request with some of these routes. So right now we've got the Coupe instance running. It's running on our local host on port 8080. And we can try one of these routes on our local host. So if we take this, we copy that route, and we go over to something like Postman, and we paste it in here, and we send the request, we're not going to get anything initially. We're going to get a 404, and that's because we have not replaced the provider parameters in this case. As I noted earlier, these host and ID parameters, they mean something particular to each provider, so you really have to go to the provider's documentation to figure out what values you want to put in place of those parameter placeholders. So if we go to the Socrata providers GitHub README, we get a little bit more information on the host and ID parameter. And in this case, the host is actually referring to the domain of a particular Socrata resource page. And the ID is pointing to a particular resource on that page. So in this example, we could use this data.ct.gov as our host value. So if I take that and I go back here and paste that in, and then take this example resource ID and paste that in to the ID placeholder, and I send it off, then I'm actually going to get a response from Coupe. And this is a feature service information response. Now, we can actually look at the data by adding the layer parameter, which is always defaults to a 0, and then the method parameter, which if you're trying to get data from a Geoservices query, the method's always going to be query. So you can put that in there and then fire that off. And now we're going to actually get some data here to look at. So if we go to features, these are features coming from that Socrata page. These will match exactly what is on that Socrata page. So if we were to actually visit this data, this is the data in Socrata form. And Coupe has actually reached out to this page. It's pulled this data, but it's formatted it as feature service JSON. And you can see that here. For instance, location address, 51 Main Street. And if you look here, location address, 51 Main Street. Let's take it one step farther, where instead of just requesting data from Coupe through Postman, we try to get ArcGIS Online to use a Coupe service in a web map. So if you want to do that, what you really need to do is you need to add your Coupe service as an item to your ArcGIS Online account. Now, can't exactly directly add what we've started with the Koop CLI. We can't add our local Coupe instance yet because of a few reasons. One, we haven't launched it with HTTPS, which ArcGIS Online requires. And two, you can't use local host resources in ArcGIS Online. So what you can do, if you've got your Coupe service still running on port 8080s, you can use a tool called ngrok to open up a tunnel to your local host that ArcGIS Online can reach. This is good for really testing. I wouldn't recommend doing this for any kind of production resource. So with ngrok, what you can do is, I've got ngrok installed here. You can look that up on Google. But you can use ngrok to tunnel to a specific port. So in this case, I'm going to say ngrok HTTP 8080. and ngrok starts up, and now it gives me an HTTPS URL to my localhost 8080 application. So if I take this now and use that as the root, and then I put that feature service route on it, the one that we used to get that Socrata data, which was right here. And notice I'm using the feature server /0, that 0 layer route. ArcGIS Online recognizes that now. We'll just call this Socrata test. Give it a tag and try to add it. And there we have it. ArcGIS Online has loaded up this layer, this Coupe layer. And if you go back, you can see on the ngrok output here that these requests have been made. These requests are coming directly from ArcGIS Online. And now if we go open this up in a map viewer, we'll see all this Socrata data flowing from that original Socrata page. The data is still in place on the Socrata page. It's being pulled by Coupe, transformed into feature service JSON, and added to this ArcGIS Online web map. And you can even use a pop-up to get the specific property data for each of the features. One last thing to discuss before we move on from this part of the demo. We're serving data out to this ArcGIS client now, and if we go back to our terminal where we're running Coupe, you're going to notice some warnings being printed. It's important to note that these are just warnings, these aren't errors, so the data is being served. It's just giving you a little bit of information here that might be of value. The first warning is about invalid GeoJSON being served out by this request endpoint. Again, this is just a warning. All this means is that the GeoJSON coming out of the provider doesn't adhere to the GeoJSON spec in some way. In this case, it's a way that doesn't break anything in Coupe. I don't know what it is specifically offhand about this GeoJSON that is failing the validator. It's probably something very minor. But again, it's a very strict validator, so this in most cases can be ignored. The other warning is about an ID field assignment. An ID field assignment is essentially property in the GeoJSON's metadata object, and it tells Coupe which property of the GeoJSON to treat as an object ID. Most ArcGIS clients need an object ID, and so using an ID field property in the GeoJSON's metadata object, you can essentially map which of the GeoJSON properties is going to act as an object ID. And if you don't assign an ID field, you're going to get this warning because Coupe knows that most ArcGIS clients want something to serve as an object ID. In the event that you don't assign an ID field mapping to another property to act as an object ID, you get this warning, and then Coupe will go and create its own object ID field by numerically hashing each feature. And that actually works pretty good. There might be some degradation of performance due to the hashing that has to be done, but if you don't have anything to serve as an object ID in your GeoJSON, then that's provided for you. Again, these warnings can be ignored. and they can even be turned off. Next, we're going to create our own provider plugin using the Koop CLI and add it to this Koop instance we've been working through. For the purposes of this demo, I thought it would be fun to create a Koop data provider for the Geonames API. If you're not familiar with Geonames API, you can go check it out at geonames.org. It's essentially a place to search for names and find their location. So if I were to type in, let's say London, and do a search, it brings back a list of places with the name London or related to the name London, and it's sorted by the one they think you're probably looking for. Most people would be looking for the London in the United Kingdom. In addition to this user interface, Geonames has an API that we can interact with. We can pull the data down as JSON, and then we can use Coupe to convert it to GeoJSON and then on to feature service JSON or whatever other Coupe output plugin we happen to be using. In order to use that API, you need a Geonames account, and you need to activate the API usage, which I've already done on this account here. Here's a quick look at the Geonames API response for that search for London. Difficult to read here, but you get the gist. It's a bunch of JSON. It shows the first 10 results by default. We're going to use the Koop CLI to generate the boilerplate that is required when you start developing a new provider. And to do that, we'll do Koop new provider, and then we'll give it a name. Let's call it Koop provider Geonames. And Koop's going to generate a directory and the file structure we need to get going. You'll notice up here now in my File Explorer that there is a new directory called Koop provider Geonames. This is all of the files that the Koop CLI has generated for us to get going. So let's just take a quick walk through the files that have been generated. As with the Koop instance, it is a Git repository. So you'll notice a git ignore file. You'll also notice the package.json and package lock.json that goes along with this being an NPM. You're going to finally notice in the root, you're going to notice this koop.json file. And that file helps the CLI understand this provider, provide some metadata for the CLI to operate on. The other files we should look at are the source files. There's this src source directory that you'll want to look in, and you'll notice first an index file, and the index file essentially exports this object, and this object is what Coupe uses to register the provider. So there shouldn't really be much to change here unless you want to change which of those route parameters are going to be available or made available by this provider. You might remember a little ways back we talked about the host and the ID parameter. Well, that's where these get set right here. So if the value of hosts is true, then the host parameter will be part of the routes. And this is a little counterintuitive here, but if the value of disable ID parameter is true, then there won't be an ID parameter. And you'll notice that there's reference back to this coop.json file. The values for a lot of these things are coming from that coop.json file. So if you do want to change something like whether or not the hosts parameter is made available on the route, then you should go to coop.json and change the values in the allowed params object. So for instance here, we're saying that the host parameter is not going to be part of this provider's routes. But if we wanted it to, we would just simply change this to true, and that host parameter would end up being added to the route. Some things we do want to change on this straight away are the name of the provider. Koop CLI, you can see, just puts in a generic name. So we'll change this to, I don't know, Koop provider Geonames. And maybe we'll change the version to 1.0.0. Let's try that. Probably the most important file for development is this model.js file. And the model.js file exports a model class. Here it's using the old style function notation. But if you prefer the class syntax, you could replace this with class syntax. But anyway, we'll just stick with what Koop CLI generates for us now. It creates a model class and a prototype function on that class called getData. And getData is the one function that every provider's model class must have. It is a function that has two arguments. The first one is the express request object, and the second one is a callback to be fired once you've got the data and turned it into GeoJSON. So Koop CLI creates a getData prototype method here for you with a very simple stub, just a empty GeoJSON that gets passed into the callback. The callback expects GeoJSON for its second parameter. If there's any error, callback should return that error as its first argument. We can add the code for a local provider with the Koop CLI, even though the provider isn't currently published to NPM. Koop CLI is smart enough to look for a local directory with the provider name. So by simply doing a Koop add provider, Koop provider geonames, we should be able to register this provider with the Koop instance that we already have going. So now if we go to our application plugins folder, you'll notice that there's a second provider that's been added, Koop provider geonames. So now if I do a Koop serve, you're going to notice that we have a new set of routes, Geoservice routes, that are attached to the Koop provider geonames provider. And notice that there's just a ID parameter, no host parameter. And that's because we have set up this provider to only use an ID parameter and told it to disable the host parameter. Okay, let's test out this new provider that we've attached to our Koop instance. So it's Koop provider geonames, REST services, an ID parameter, feature server, so on and so forth. So if I go back over to Postman and I change my path, so that is Koop provider geonames, REST services, and then I'm just going to have an ID parameter. And right now, we haven't done any development work on the provider, so it doesn't really matter what we put in the ID parameter. I'm going to do this, just put a dummy string in there, test, and we get a response back, a query response back, and notice that there are no features. Well, that makes sense because back in our provider code, we're just returning this GeoJSON object, and notice there's no features. So that's simply a test to make sure that this is all working. What I want to do now is I want to talk about debugging in Visual Studio Code and VS Code, and how it can help you develop your Coupe provider. So to debug, you want to come over to this little run icon, and if this is your first time in the project and you haven't created a launch JSON file, it's going to prompt you to do so. So you can just choose that, and you can go to Node. It's going to create this JSON file that sets up the debugger for your program. So we need to make some adjustments here to what is the default in order to get the debugger hooked up to Coupe. Now this is what you want your launch JSON file to look like. Very, very simple. It's type node request launch. Give it whatever kind of name you want. We can just call it launch Coupe. The most important part here is this program property. You want that to be pointing towards the source index file. And I usually put my console as an integrated terminal. So given that, what we can do is we can start up Coupe using the Visual Studio Debugger. You want to make sure that you've killed the Coupe serve command that you have been doing, because it's using that. It's already running on that port, so we need to kill that. And now with our launch JSON, we can start the debugger, and you're going to see some terminal output. You can see the debugger's attached, and then it's got the exact same console output that we had before. So now what you can do is you can go to that model, and you can put in a breakpoint. You just put in a breakpoint over there, and if we go back to Postman and fire that request, you're going to see that VS Code now breaks right in the getData function. And we can inspect variables and what have you. I've added some basic code comments here to outline the development of this Geonames search provider. And here's what they are. And the first thing you want to do is we're going to have to pull something out of the request to serve as the search term in the Geonames API request. So if you remember earlier in the example, I searched for the term London, and the Geonames API returned several records for that search it did on the term London. So for each request coming in through Coupe, we need to determine what search term we're going to send on to the Geonames API. Once we do that, then we can build the search URL, the Geonames search URL, and then we're going to make the request to Geonames. We're going to get the response back from Geonames, which is going to be Geonames formatted JSON, and we're going to transform that to GeoJSON. Finally, we're going to add some metadata to that GeoJSON object. If there's any errors, we want to make sure to handle those. And then finally, when we have either our GeoJSON or some handled error, we're going to execute the callback properly for either of those situations. Let's start by determining what we're going to search for on Geonames. So as noted up here, one of the parameters of the getData method is the express request object. So we can use that to get the ID parameter from the express request. Next, we're going to build that search URL. The Geonames API search URL looks something like this. I have built this URL up using the ID parameter that we've taken from the express request object. So I have pasted that in this string template. So whatever comes in as the value of the ID parameter is going to be the search term in our request to the Geonames API. There's also another query parameter on here called username. That is the username of your Geonames account. I've made it a constant here and just define that up here for now. Now we want to pass on this request to the Geonames API. And to facilitate that, it's good to use a request library. I usually use node fetch, so I can do an npm install save. You want to save that because you want that to be part of the provider's package JSON, and just do a save node fetch. That'll install, and now we can pull that dependency in. We'll just call it fetch and require it. In advance of making the request to Geonames for the data that we're going to transform to GeoJSON, I have prepped this getData function. I've converted it to an async function, and I have added a try catch block here to hold the call to the Geonames API. So making the fetch to Geonames is something simple like this. We're just awaiting this fetch function, and we're going to get a response back. Next, we're going to want to check to make sure the response worked out. You're going to check the OK on the response from fetch, and if it's not OK, you want to throw an error with the status text, and we'll handle that error a little bit later. Assuming that the fetch was okay, you just want to do a second await here and get the JSON for the response. The next step in provider development is creating a transform function that's going to transform the JSON coming out of Geonames into GeoJSON. So right here I've got a sample response from the Geonames API, so this is what the JSON is going to look like. And you're going to see that there's a Geonames array, and inside of that array is a list of objects. And I've got one of the objects highlighted right here. Now to turn this into GeoJSON is pretty simple. We are going to simply look for latitude and longitude, which we have here. We've got a lat and we've got a longitude. Note that they're strings, so we're going to have to convert those to numbers. Everything else in this object should go into a GeoJSON property. The latitude and longitude goes into the GeoJSON's geometry coordinates. Everything else we can just stuff into GeoJSON properties. So you can see I've plopped in a function here called transform Geonames to GeoJSON. So let's take a look at the guts of that function. And so here it is, and it takes the JSON from Geonames, destructures that JSON so that we get the records array. If you remember, there was a records array, and it maps that records array to features using another function called transform record to feature. And once it gets those features, it sends back a GeoJSON feature collection object. Just to take a step down into that transform record to feature function, you'll see it here. It gets the Geonames record and it destructures it so that you get the latitude and the longitude, as well as the rest of the properties of that Geonames record, and then puts it into a GeoJSON feature object. A feature object has a type property, which is always feature, and then it has a properties object, as well as a geometry object. And you can see here the geometry object I have built up as a point type. Geonames, I believe, only returns point geometry, so This is fairly easy to do. We don't have to look at the geometry returned from Geonames to determine what type it is. It's always going to be a point. And then we take the latitude and longitude, cast them to numbers as the coordinates. So just to reiterate, we loop through the records array that comes from Geonames, and we transform each of those records to a GeoJSON feature. And we put those into a features array that is inside of a GeoJSON feature collection object. A couple of remaining steps here. So we've got the GeoJSON now, and what you want to do is you want to add a property to that GeoJSON object titled metadata, and it's going to be an object, and most importantly is to include a property in that metadata called geometry type, and assign it the whatever value, whatever type of geometry that your data is going to be. As noted earlier, Geonames search data is all point data as far as I know, so I can feel pretty safe in hard coding this geometry type as point. Other remote APIs that may return data sets in varying geometry types, you would want to set this dynamically. You can also set a description here. This will come through on some of the metadata responses. You can also set a description that can be useful. There's several other metadata properties that you can set. Description is one, but it is optional. It's not necessary. Finally, or maybe not quite finally, you need to execute the callback. And it's an error first callback. So in this case, if we get this far, there's no errors. You set that first argument to null, and then you pass in the GeoJSON as the second argument. In your catch block, you're going to want to execute that callback as well. The difference being that you are going to pass in the error as the first argument of the callback. And that's pretty much it. We can start up our debugger, and we can go over to Postman. And you'll notice that I've put London in as our ID parameter. And I'm going to execute the query request. And I get back the Geoservices API response with a features array, and here are some of our features. You can see that the attributes have been populated as well as the geometry. I can change from London. Let's try Seattle. And again, I'm going to get some data here. Features Seattle with correct geometry. Just to wrap up our demonstration, I wanted to add this Coop service that we've just built to ArcGIS Online, much as we did earlier with the Socrata Coupe provider. And there are the points coming from the Geonames API once they've gone through Coupe. Well, I'd like to thank you for joining us for this Coupe demonstration. I really want to thank all my colleagues at Esri, and especially Haliang Yu for his work on the Koop CLI. If you're interested in looking at the code that I developed for this demonstration, specifically the Geonames provider code, you can find it on the Coupe.js GitHub organization under Coupe Provider Geonames. And just to reiterate, you can get more information about Coupe at our documentation site, coopjs.github.io. Check out our GitHub org where you can scan the code for a lot of our plugins. And you can feel free to reach out to us via email, via our GitHub organization issues, or the Spatial Community Slack channel. Please get in touch if you have questions and consider contributing to this open source project. We would really appreciate it. Thanks again to Esri for putting together Dev Summit, and if you'd like to provide some feedback, you can do so by clicking the session survey link directly below this video. Take care.